Okay, so we're starting graphing linear equations today, and the first thing we need to know is standard form for a linear equation. Standard form looks like this, with each capital letter representing a number. So you're going to have some number times x plus some number times y equals some other number. And this is called standard form. It has to be x plus y equals c. So the x-intercept is where our line is going to cross the x-axis, and the y-intercept is where the line will cross the y-axis. And I'm going to show you how to find those two things today. And we're going to talk about how to graph a line on a coordinate plane. So the first section says, determine whether each equation is linear or not. If so, write the equation in standard form. So we can tell if an equation is linear if it is just x plus y equals 0. So look at number 4. This little thing right here makes the equation not linear. So number 4 is a big no. As soon as you see an exponent on one of your variables, that is not a linear equation anymore. Linear has to be just x plus y equals 0. Another example of linear could be just something y equals a number or just something x equals a number. So in this number 5, because we don't have any exponents, we just have 3y plus 2 equals 0. That is linear. So you're going to just write this stuff down. I know it doesn't make total sense now, but the more we do, the better you're going to understand it. And then it says to write it in standard form if it's linear. So I need x plus y equals 0. Well, I don't have x, but I can make it y equals something, right? So I'm going to move this 2 to the other side, just like solving an equation. And now that would be considered standard form because I have 3y equals -2. So number 6, because I have a fraction times x and a fraction times y, then it is linear. Just because it's a fraction doesn't mean it's not linear. It's still linear because I have no exponents on my variables and I just have something x plus something y equals a number. And it's already in standard form. Remember, x plus y equals a number is standard form. Now number 7, so number 7 is different because what do you notice about the variable y?
It's the denominator.
It is the denominator in a fraction. Nice job with the vocab there, Rayleigh. So anytime your variable is in a denominator, guess what?
It is not.
It is not linear. Immediately takes it out of the game. When there's a variable in the denominator, it is not linear anymore. So number bonus question, is that linear or not linear?
Not linear.
Not linear, because it has an x in the denominator. That will not be linear. So for number 8, it says graph each equation. When I am graphing a line, there's a couple different ways to do it, but they started us off with a very easy one. X equals 3. And I'm going to make it green, and I'm going to graph it in green because I'm going to show you another example too. So x equals 3 means I need to go to the x-axis, and I need to go to the number 3 on the x-axis. Here's 3, right? If x equals 3, my line is going to be vertical. If it's x equals something, you're going to have a straight vertical line. And when you graph a line, you're always going to label that line like this. You're just labeling it with the equation. So I'm going to show you another example as well, and that's if we had y equals something. Let's do y equals -2. I'm going to graph this one in red so you can see the difference. I know. So if y equals -2, now I need to go to the y-axis and graph -2, which is right there. So what kind of a line do you think I'll have now?
Oh, it's gonna, yeah.
Good, horizontal.
Wait, didn't you just say it'd be a different graph?
Well, I did, but I changed my mind because I need to show you what y equals looks like. So for this one only, you can have two lines on the same graph. Okay, so you need to remember that x equals is going to be a vertical line and y equals is going to be a horizontal line. So for this equation, it says x minus y equals 0, and it says graph the equation. So there's two different ways that we can graph equations. We can make an xy table. We can pick some values for x. You literally pick whatever values you want, but I try to stay close to 0 because if you pick big numbers, you're going to get like crazy graphs sometimes. So I try to do numbers that are close to 0. You should pick at least 4. You can do 5, at least 4 though. So this is one way. You would plug in all those numbers for x and see what y equals. But another way to do it is by finding the x-intercept and the y-intercept. So if I want to find the x-intercept, I'm going to let y equal 0. And when I want to find the y-intercept, I'm going to let x equal 0. Okay, so this is a much easier way to graph with the intercepts than it is to make the whole table thing. Because you can see I only have 2 that I need to find, whereas with the table I have 5 that I'm trying to find. So if I let y equal 0, that means I'm just going to do a 0 instead of y. So x minus 0 is just x equals 0. Oh, so this is interesting. When y is 0, x is 0. And we're going to do the same thing. We're going to let x equal 0 now. So 0 minus y equals 0. And I can't end with a negative on my variable, so I'm just going to divide by -1 to get rid of that negative. And y is still going to equal 0. Doing the x and y intercept for this equation wasn't helpful because we ended up with only 1 point on our graph. We have to have at least 2 to make a line. So we're going to have to go into our xy table, plug in these values for x, and see what y equals. So if I plug in a -2 for x, I get -2 minus y equals 0, and then I have to solve. So I'm going to add 2 to both sides. And then I have to get rid of that negative on the y. So when x is -2, y is also -2. And we already did 0. Remember, we plugged in 0, we got 0. So that one's done. So let's plug in -1. So -1 minus y equals 0. This time I'm going to move my y so I don't have to do as much work. So when x is -1, y is -1. Do you see a pattern?
No, I just see
Look at the XY table. Yeah. Whatever X is, Y is, right? Okay, so that means if I plug 1 in, I'm going to get 1. If I plug 2 in, I'm going to get 2. So now I'm going to plot those points on my graph, and that's going to help me make my line. So -2, -2, -1, -1, 1, 1, and 2, 2. Connect the dots, and there's my line for this equation. X minus y equals 0. Remember that whatever you pick, you have to graph. That's why I don't pick like 10 or 12, because if you pick 10 or 12, then you got to go out 10 on the x-axis, and that's a long way. So I like to keep it close to my origin. All right, so we're going to use an XY table to graph this line. We picked 4 values for x, and we're going to plug them in and solve. So y equals 2 times -1 is my first x value, plus 8. 2 times -1 is what? -2. Awesome. And then bring down the plus 8. What is -2 plus 8?
-2 plus 8, that'd be 10. -10. It's just 10. 6.
6. Good.
Oh, yeah.
Next value that we picked for x is 0, and I always like picking 0 because it's super easy to solve. So
Did you say X? You put Y.
Because I'm plugging in the x. Do you see the 0?
See, that's what confuses me.
The 0 is where the x was, because it's on my x side of my table.
Oh, so this is exactly like what we were doing before. Okay.
Yeah.
No, this is
Okay, so 2 times 0 is 0, so this just leaves me with 8. So when x is 0, y is 8. I think maybe I should have picked more negative numbers on this one, but that's okay. Okay, so let's plug in positive 1 now. So y equals 2 times 1 plus 8. So 2 times 1 is 2 plus 8. Yes. So when x is 1, y is 10. Does anybody see a pattern with the y values?
It's going by 2.
It's going up by 2. So what do you think 2 will be?
12.
12. When we plug in 2, we're going to get 12. So let's go ahead and graph this line. So I'm going to do -1 and 6, which is up here. Then I have 0 and 8. Oh my goodness, this graph is going to go off the charts.
I still graphed it.
Then I have 1 and 10. And then I have 2 and 12. Okay.
Can I count it by 2s instead? Like 2, 4, 6, 8, 10, 12. Because I'm not going to have enough.
Yeah. All right, and so there's our line. Y equals 2x plus 8. And remember, when you draw the line, you have to write the equation at the line, so you know what equation that line is. All right, that's all for today, so let me know if you have any questions. We're going to do more of this next week, and it will make more sense.